2.5, completing the square. A couple of your problems on the online assignment the other day, those are the ones you skipped, were completing the square. And in this curriculum, I think they start completing the square in Algebra 1. So it was kind of a prequel to see if what you remembered. So this whole section is about completing the square. If you notice your assignment today, we do evens, tomorrow we do odds. And so do you think it's really important that you know how to do it?
Yes.
Yes. Okay, now completing the square is not something that you're going to go to all the time. And I personally only do it when, like, I can use it to solve an equation if it tells me to solve an equation. But the only time I do it is to write it to vertex form. What would be nice about writing a quadratic in a vertex form?
It's easier to graph.
It's easier to graph, right? I have got my h, my k, I've got everything right there. And then I can solve it for there and get my my x-intercepts and really be on a good track. So, but it's not something I choose when I see a quadratic equation. I will factor or use the quadratic formula. I don't go, ooh, look, I can complete the square. But it is kind of a fun thing to do. I know. It's not that hard, but it is a process, and you've got to do the process several times. So on the left, we have a solution, and on the right, they have a solution. You can clearly see they're not the same. They didn't do them the same, but did they come out with the same answer?
Yes.
Yes. So we need to go through and see if it's okay. Like, if what they did is okay. So over here, well, they have x squared minus 16 plus 9, or minus 6x plus 9 equals 16. What did they do? They subtracted 16 because they set it equal to 0. Because I told you can't factor a quadratic unless it's equal to what? 0. So that's what they did. So then they have the factors of 7 that have a difference of 6. Negative 7 and positive 1. Then set both of those equal to 0, and they came out to 7 and negative 1. Okay, that worked. Well, this person over here factored the left-hand side. What are the factors of 9 that add to 6? You don't need to write this down, guys. Please don't be writing this down. This isn't a lesson. We're just talking. Okay, 3. So I have x minus 3 quantity squared, because that would be x minus 3 times x minus 3, right? Okay, then they took the square root of both sides, and the square root of 16 is positive and negative 4. Yeah? Okay, so they have x minus 3 equals 4, and x minus 3 equals negative 4 right here. And they came out with 7 and negative 1. Did they both come out with the same answer? They did. On the left, they used factoring like you have done before. On the right, what they did is partially, it would be the process of completing the square if the 16 was on the other side. So they came to the same answer. So we can do that, so that's what we're going to do. So we're going to use the square root right now to solve. These are the first 3 or 4 problems. So we complete the square in 6 problems today and do this in 3 problems. Remember that you can do this. This is what the first part of your assignment is. If your left-hand side is a perfect square, is that a perfect square?
Yes.
Okay. And if the right can be factored into a perfect square. Okay. So I have the factors of 49 that equal 14. 7 and 7. Correct? So I have 25 equals x plus 7 squared. And if that 14 was a negative, it would be x minus 7. Correct? Now, this method works as long as you can factor the trinomial into a perfect square. Okay? The right-hand side, the 25, really doesn't have to be a perfect square, but the polynomial has to be. Does everyone get me? Okay? So now what would I do? Take the square root. Correct? So because I have this quantity squared, when I take the square root, don't I just get what's inside?
Yep.
Yeah? So I get x plus 7. Well, the square root of 25 is?
No. 5 or positive or negative 5.
Positive or negative 5. It's
5
very
or 5.
important to remember that because you're leaving off a complete solution if you don't. Okay? Then how would I solve this equation?
Minus 7.
Minus 7. So I now have positive 5 minus 2 is, or minus 7 is
Negative 2.
negative 2. And negative 5 minus 7 is negative 12.
There we go.
Because we have a positive and negative 5.
Yeah.
Another way I could have written that, and sometimes I do, is 5 equals x plus 7 equals negative 5. And then subtract 7, and I get negative 2 and negative 12.
Yeah.
Okay? So either, it doesn't matter. You could write them in 2 separate ones like the first slide did. I just think that's kind of redundant. But what has to happen for this to work, guys?
It has
It has to be a perfect
be
square.
Trinomial.
perfect trinomial.
Okay. This has to be a perfect square trinomial. I told you the 25 had to be a perfect square, and it does not have to be. It could be any number because we could just leave it the square root of 29, can't we? But your trinomial has to be a perfect square for this to work. It doesn't work any other way. This is why when we have conditions on things and we forget the conditions and we try to use it all the time, does it work? No. I don't like things that have conditions. I like to use something that works all the time. That's why I say always set it equal to 0 because that will work all the time. Does that make sense? Okay, so it says use the square root. So if it's telling me to use the square root, then it probably is, yes? So over here, so I have x squared plus 12x plus 36. Factors of 36 to add to 12.
6.
6 and 6. So is it a perfect square trinomial?
Yes.
Yes. So x plus 6 squared equals 81. Then what?
So yeah, take the square root of it.
Take the square root. Then what?
Well, let me get there. So you got 9 equals x plus 6.
Positive negative plus.
Positive and negative 9 equals x plus 6. And then
you
subtract 6.
Subtract 6.
So negative 9 minus 6, negative 15.
Could be 15.
And positive 9 minus 6.
3.
Again, with me trying to do the smaller one first, that's why I did the negative first. Because I knew they were both negatives, I'd add the negatives, so it should be bigger, right? Okay, try that one on your own. Addie, your phone's gonna fall out of your pocket. I'm sure it looks like it is at least. Austin's going to do it.
What?
Yeah. Go on.
Yeah.
Okay, Austin, what'd you do first?
Alright. But 9.
Okay.
Square root of the 9.
What's the
No,
square
what's
root
the
thing?
step? You're just forgetting a step. You should have factored the right-hand side. What'd you factor the right-hand side?
X plus 8.
X plus 8?
Minus 8.
Why is it minus instead of plus?
Because Kel told me.
Why is it minus
The
instead
middle
of plus?
term is negative.
Because the middle term is negative, right? They both will have that negative sign,
Oh,
okay?
that's nice.
Oh,
Oh, really?
Weird.
Oh. Alright. I'm gonna put, since it's 9.
Now
is
take
it
the,
3.
no, not
Yeah,
just
that.
3.
That, so it's 3.
No.
9.
Square root of 9 is what?
3.
No. Plus or
Plus
minus?
minus 3.
Plus or minus 3.
Equals X plus 8.
Minus
And-
8.
Alright. And then it's. Shut up, I'm gonna change my answers.
Oh, that's okay.
Wrong or right.
Don't get it wrong.
So, it's gonna be a negative 11.
Add 8, right?
Yes. You add 8.
So it would be positive 11
Yeah.
and 5?
then the other one's a 5.
Okay, how'd it go, guys?
Good.
I did it right.
I did it right, but I
Okay,
think
I didn't know
I
you
did
had
it
to
right.
say
How about Callie?
I did it right. Otherwise, like I did the process right, but I didn't look at the negative.
Yeah,
I did. Yeah, I
Make
did.
sure you
all
look
right.
at that middle one,
That's the only thing.
okay? Make sure you look
Yeah, I
at that
did too.
middle. Now, if this side,
Exactly what you did.
if this polynomial had like a 2 all in common, would I factor that out first?
Yes.
Yeah, you'd factor it out and divide it over before you factored, wouldn't you? So just remember what you can do. So the first section of your homework is this. You do not have to complete the square. We haven't even talked about that yet, and we're gonna start. The reason I say that is in 5th hour when they hit it, they all were completing the square. You can, but that's not what it's asking you to do, okay? So just don't complete the square till you have to. Okay, completing the square is what we're doing is we're making a perfect square trinomial. Okay?
Yes.
Because right now I have x squared plus 8x plus 5. Is that a perfect square trinomial? No. I can't even factor it nice, can I? No. So what we're going to do is give ourselves a perfect square trinomial. And we're going to do that by taking and adding in this term right here. What does that say?
B over 2.
Square it.
B over 2 squared. And then once I have this, it factors into x plus or minus, because if that's a minus, right? B over 2 squared. Every time. So how we do this process. The first thing you do is you kick out your constant. Kick it out.
That's mean.
So you have x squared plus 8x plus, because we're going to square it, so is it ever going to be negative? No. Plus 5. Now, the only way I can add something to an equation without changing the equation is I have to also do what?
Take it times the other side. Something.
Well,
Do
but
to
I'm
the
on
other
one side. If I add 4 to an equation and I don't want to change the equation, what do I also have to put there?
Negative 5.
What?
Negative 5.
No, I said 4, but
Oh.
yeah, positive and negative 4, because if I put add 4 and subtract 4, what am I really adding?
Nothing.
0. That's the additive identity, correct? So whatever I put in, I also have to take out. Got it? So this will be plus and this will be minus. Whatever we put here, we put there. And I should have put that on the other side. Just because I'm going to run into the other one. Okay, so the rule says b over 2. Yes?
Yes.
What is b?
8.
8. So 8 over 2 squared. Now, always write this because when you get something, we have fractions today, and you have to square the fraction, do you want to have to think about factoring a fraction?
No.
No. And this rule says it's going to be x plus b over 2 in my factor when I'm done, right? So if I always write this right there, do I always know what it's going to factor to without having to think about it?
Yes.
Yes. Okay, so 8 over 2 is what?
4.
Squared is?
16.
So I'm going to add 16 and
Subtract 16.
subtract 16. Okay? Because I added 16 and subtracted 16, did I really add anything to this equation? No. So now I factor this. We can do this. Factors of 16 that add to 8 are what? 4. But what's 8 over 2? 4. So we get x plus 4 quantity squared. And what's this?
Minus 11.
Minus 11. Now, I want you to look at this. I had a quadratic, and if I would have told you to graph that, you would have had to do negative b over 2a, right?
Yes.
And then plugged it back in to find the y, and then all this stuff. But what did I just put it into?
Vertex form.
The vertex form.
So you got negative 4.
So I know that it's going to go left 4 and down 11, yes?
Yeah.
So I knew that without having to do negative b over 2a.
Gosh, dang.
But guys, did you just do b over 2?
Slowly.
Okay, and what is a?
A.
1.
1.
Okay, you just did b over 2a. And you squared it so you didn't have the negative. Yes,
How'd you figure out the 16?
Because the 8 is a
8 is b. So b divided by 2 is 4. 4 squared is 16. Every time. Okay, now I have my vertex, yes?
Yes.
My vertex would be negative 4, negative 11.
Mm-hmm.
Now the only other thing I would need are my x-intercepts, right? How do I find x-intercepts? Set it equal to 0, right? Yes.
Okay, you said the vertex would be negative 4 and negative 11?
Yeah.
Why would it be negative 4?
Because it's always opposite on the h. Remember?
That's written as
I
y.
do now.
That's written as y equals a parentheses x minus h
Because
squared
it's-
plus k.
X minus h squared plus k. So that h is always the opposite. Always. Okay, so now I set it equals 0 and solve, right?
Yes.
How would I solve this? Add 11.
Yeah.
Okay, so it'd be 11 equals x plus 4 squared. Then what?
Where
Square root them.
Square root it.
Square root them, boy.
So I have plus or minus the square root of 11 equals x plus 4. Yes?
Yes.
Like
Minus
it.
4.
And then minus 4. So x would equal negative 4 plus or minus the square root of 11. Now, square root of 11 is going to be, well, square root of 16 is 4. So, right? So, like, the square root of 11 would be like 3.4.
Something.
Okay, so not quite
One of those
4. So could you approximate that in there? Yeah. So if we said this was like 3.4, how about that? So if we said that's 3.4,
Do we have to?
negative and negative, we'd have x would be approximately negative 7.4. Negative and negative, just add them, right?
Yeah.
Yeah. Negative 4 minus 3.4 would be negative 7.4.
Yeah.
Okay. And then if I have negative 4 plus 3.4, so that would be negative 0.6.
Yeah.
Okay, so do I have approximate x-intercepts that I could use as well?
Unfortunately.
Okay, so this is a way that I can use to graph as well. And that vertex form is a lot easier to use than standard form, isn't it?
Who is that?
You think she knows?
What? X is approximately?
That's what.
I thought it was just 2 x's for a second. I figured
No.
I have no clue what that is. Still.
I've never seen that in my life.
Well, you should have.
Oh.
Oh, they're so close together. I thought that
I
was
thought-
like a different X.
Yeah, it looks like a different egg.
No, it's just the pin jump.
No.
Yeah.
Sure. It didn't jump
Yeah,
up.
if you are not putting an exact answer, you have to put an approximate. I will take off for that.
Seriously.
Okay,
What is
but what is my answer? I could just leave my answer like this, yes?
burning fire?
What would be the only reason I'd need this if I were having to graph it, yes? But I didn't ask for exact. We didn't use a calculator, right?
No.
That's why I could put approximately and I was okay.
Yeah.
You all can judge square roots pretty close.
Okay.
We could be wrong. It'd be 3.6, but I'm not going to.
3.5.
Well then.
Okay, I doubt it's 3.5. Okay, so now I did tell you to notice that the coefficient here was 1. You cannot complete the square unless the coefficient is 1. If the coefficient isn't 1 after you kick out C, you have to factor it out of the first two. But I don't think any of your problems do that. I don't think any of your problems do that. So I think everything has 1. I torture you with that next year.
No.
Okay, so x squared minus 6x minus 11 equals 0. First thing I do is kick out my constant.
11.
Okay, so I have x squared minus 6x plus, why is it always going to be plus?
Because it's
So it can work out in the end.
Because you're squaring it.
yeah.
And then minus.
That is, I don't want to.
So next, what do I do?
You do the b over 2 squared.
Okay, so b is
Negative 6.
negative 6 over 2 squared. Now the negative doesn't matter for my squaring part, does it? But when I factor, does it matter?
Yes.
Because my quantity is going to be negative.
So it's 9.
So half of 6 is 3, squared is 9. So I add it and
Subtract it.
subtract it.
Hey, I said that.
So factor. So x
No.
minus 3 squared minus 20 equals 0. So I now know my vertex went 3 right and 20 down, correct?
Yes, you yeah.
And if I needed my x-intercepts, then I would solve.
Yes, you would.
Mm-hmm.
So I would do what?
You would solve it.
Write that down on your paper and call it good.
Add
Oh,
20
why
on both
not?
sides.
How would I solve
Square
that?
root them.
Add 20
Nope.
to both sides.
I would add
to both
20.
sides. Then you square root them.
And then you square root.
It's very important. 20 has to be separated. You cannot square root that quantity because there's 2 terms there. You can't square root those. Doesn't
Okay.
work. Okay, square root. Square root. So x minus 3. Now I need this. I don't know why I put parentheses. You don't need parentheses anymore.
Well, like it's
Square
good.
Okay.
Plus or minus square root of
But square root of 20 I can break down. Square root of 20 is what?
5. No, 4.
5.
5.
5 and square root of 4.
So
4.
No.
opposite way. You have no.
4
You have 4 times 5, correct?
Yes.
What is the square root of 4?
Two.
2. So you have plus or minus 2 square root of 5.
I'm sorry.
Using our geometry here. Okay, now what?
You.
Well, I think we just add
Plus
3 to both
3.
sides.
Add 3.
It'll be a plus.
So we have x equals 3 plus or minus 2 square root of 5.
Wow, we're good at math.
And if I had to approximate those 2 square root of 5 would be like 2 point something, right?
2
So
point
So
we
you
don't
have
have
to
to
take
put
2
it
times that.
approximately for the x equals 2.
No, because I didn't approximate anything. Like, do you see that, Callie? I did not approximate anything. The square root of 4 was 2. There's nothing. Like, if I said, well, square root of 5 is like 2.2, then I take 2.2 times 2. So that would be 4.4. Then I would have to use it approximately because I don't know if it's 2.2. So this put it into vertex form, didn't it?
Bam.
Yeah.
Yeah.
Okay. Once I solved it, what did I find? What are these?
Those are the
No, these aren't x-intercepts. These are
Those are the solutions.
solutions.
I said it.
What
first.
makes them x-intercepts?
Okay.
when they're set
When you
equal
set
to
equal
0.
to 0.
No, they already were set equal to
Well,
0.
that's a shame.
Written or
When you put them down.
When you do that.
Approximate them?
Order
No.
pair.
Thank you, Evan.
Oh.
Why did I do this? Why did
Because Evan was the only one that said it.
Oh.
Okay, when I put them into an ordered pair, they're x-intercepts.
Yeah, I said it. He copied me.
Oh, well, I only heard him,
He
sorry.
cheated.
Okay.
That's what I did to Autumn.
So,
Did we need to have
He
those
used to do that for a while.
solutions?
no,
Okay.
I just, they were solutions and then they were x-intercepts. I was showing you the difference. Okay, so now it says, before it didn't say solve, did it? It just said completing the square. We took it further and solved it. So have we already solved them?
Yeah.
Yes. So, what do I do first?
Take
Take out the 3.
Take out the
Write
3.
it down.
Yes, you would write it down.
No, you take out the 3, because 3's not cool.
Well,
Evan.
you're not cool.
Evan, stop being so smart.
Guys, someone trying to listen to this would have a very difficult time, and somebody who's struggling in this room would have a very difficult time. You need to stop with the comments. Yes,
Why did you change it to adding instead of subtracting?
I just changed it. Because I wrote it down wrong.
Okay.
Because I wrote it down. Because there was too many distractions behind me.
Might be.
That door.
Okay. You don't change the sign, right? Okay, now what?
You, the 2, the negative 2, with the B thing.
So
-2 over 2
equals
squared.
So 1,
1 squared is
1,
1.
So plus 1 minus 1. So x minus 1
So I put it in vertex form, I could graph it, right? And to solve it, when I'm solving, why am I solving, guys? What am I finding? The x-intercepts. That's the whole point, right? So I hope you subtracted 2. Did you subtract 2?
Yes.
Heck yeah.
And then you took the square root,
Root of the.
and so now you have plus or minus what?
1.
I.
Wait, why would you subtract?
So you got square root of 2.
I squared.
Why would you subtract 2?
I.
Why would I subtract 2? Because it's add.
Okay,
Then
then
you have to subtract.
Is it I
You want to get rid of
squared
it.
or is
You
it
gotta
I?
have it at 0.
Okay, I'm taking the square root of a it's going to be a non-real solution, yes? Okay, so it's going to be the square root of 2i equals x minus 1, and then add 1, yes?
Yes.
So x equals 1 plus or minus the square root of 2i. Now, it is a non-real solution. It is a solution, yes? But it's not a real solution. So if it's not a real solution, that means there's no x-intercept. Now, let's go back to the vertex form. Should we known we were going to get no x-intercepts? Look at it. Where'd the vertex go?
X
Vertex went
It went
above the
up
x-axis.
to, yes,
down.
and it's opening what?
Up.
Up. So if it's going up to and if it's opening up, is it going to have any x-intercepts? No.
Why did you put
No.
I again?
What?
Why did you put the I again?
Because you had -2. You had a square root of a negative number,
Okay.
and the square root of -1 is I, correct? Huh. So try the next one.
There you go. Touched it.
Is that your worksheet under your desk?
Yes.
Don't forget it.
Who gets it?
And they do give you fractions today, guys.
Exactly.
Why didn't the examples give us?
I don't know. I just use the examples from the book.
If the examples don't give you fractions, then why should the book?
Because
You know how to add fractions.
Because I say the book will mess you up. Okay?
The book does mess me up. It messes with
We'll
my
give
brain.
ourselves fractions on the next one. We'll make it into a fraction.
No. No, I'm not doing the next
Do
one.
that. Exactly.
Why wouldn't we?
Plus 3.
Isaiah just said he needed a fraction.
Oh, look at him though.
Did you have 2 or 3 in your?
I need fractions too.
Shut up, Joe.
So we know how to do it when it comes to the assignment.
Okay, you guys got this done yet?
No.
You're
Yes.
flapping your gums a lot.
I get
No time!
Shh. They were talking. That's why I asked Austin.
Well,
Is that 8?
I got us something.
Oh, that's.
I get lost.
I got some more. I got some
That was 0.
I don't think well, I'm not that far.
I'm that box.
An 8?
Almost done. So
Oh,
we
4,
can
2 things on bottom right.
It was
you're
very
too good.
tough to hack me, okay?
Oh,
His,
okay.
his jaw broke. He's just stuck like that forever.
How did you get that? I'm not even looking up.
Okay, no, wait, stop. It's all on the board how I got that.
Yeah, it is.
Everything is on the board how I got that.
I just forgot something.
Okay. Because it's b over 2 squared. Half of 4 is 2. 2 squared is 4.
No, I got those, but why did you write it x plus 2 squared? That's what
Because what is 4 over 2?
I'm 2.
2. Okay, the other thing is the factors of 4 that add to 4.
Wait, you wouldn't square those?
What are the
Yeah.
factors of 4 that add to 4?
2.
2. Again, that's where I got it.
Oh, wait, 2 squared is 4. Breaking news.
What goes in there is not squared, Ethan. That's why the square is on the outside.
Yeah,
Okay, so now subtract 4, and you're going to get a non-real solution again, correct?
I hope so.
Square root. So x plus 2 equals plus or minus 2 I.
Backwards.
Yeah.
Yay.
Okay, square root of 4 is 2.
oh crap, why did I put 2 squared?
I don't know.
This is where it got lost.
Okay,
Wait.
that's easy because what you got what square after this?
Why would it be?
I made it to the step right, like the square root of the
Mhm.
negative 4 and the x plus 2 squared, and then after that I got
Okay, what is the square root of 4?
2.
2. Isaiah, what is the square root of 4?
4 is 2.
Okay, so how did I get 2i?
I don't know because it's
What is the square root of 4?
2.
2. What happens when
Oh,
you have a
but-
negative and a square root? What do you get?
Then you get
I.
Oh, I get it now.
So one
That
thing I
makes
knew.
sense.
You have to combine stuff. Everything combines.
No, just take out the negative.
Okay,
Okay.
now subtract 2, yes?
Both sides and you get x equals negative 2 plus minus 2.
Oh my god. Now look at me.
Okay,
Look at this.
you have to remember things from other sections. They don't just go away.
I think they do.
Obviously not considering you're
No,
not
it's supposed to be like,
Yeah.
no, I don't think
Gail, I'm doing
It
this
is.
better
Okay,
than I
so
thought.
we're going to make these fractions.
There's 2, but
What?
Natalie's head. I say Natalie's
Get a
head.
smaller head, Natalie.
With the
What an ego.
Negative 2 also negative 2i.
Okay, so I basically got that. So basically.
So I can't wait.
Okay, so we're going to make this fractions.
No. We are not. Don't do it.
3.
Why?
I just died.
Because Isaiah wanted this.
2.
So that we could actually know how
Okay.
to do it.
Guys, stop. They're fractions. You're going to have them on every test. You're going to factor on every test. It's going to be there forever. They're not going to wait. Go away, so get over it. Okay, so x squared minus 8/3 x plus 17 halves. Don't know what this is going to look like when we're done, but we're going to do it. We are bigger than them.
No.
Okay, so what do we do first?
Get out our 17 halves.
Kick out the 17 halves.
Good start.
My career doesn't look like over an 8.
Okay. Now I take b divided by 2. Okay, when I divide by 2, I really multiply by
It's reciprocal.
its reciprocal, which is what?
Half.
A half. What you're dividing by, you reciprocate. So the reciprocal of 2 is
1/2.
1/2. Yes?
Yeah.
Okay. Does 2 go into 8?
Yes.
4 times.
One goes into
So
2.
I have negative 4 over 3 squared. Just took it slow, didn't I?
Yes.
So, is 16/9. Yes?
Yeah.
So I added 16/9. I have to.
Subtract 16 ninths.
Okay. So I told you specifically make sure to show this work for this reason. Because I need to factor that trinomial, yes?
Yes.
This is it. That's what I'm gonna put there, isn't it? So I'm gonna have x minus 4/3 quantity squared. I'm not going to think about the factors of 16/9 that add to 8/3.
No.
I don't want to do
I
that.
already did.
And if I did this, my answer is what?
Negative
Right
4/3.
there. Okay? So now over here I need to get common denominators, yes? So I have to multiply this by what? 9, and this by 2. So my common denominator is going to be 18. See? So 9 is 3, carries 6, so 153
Yeah.
minus 32. I just multiplied 9 times 17.
121.
Not 153.
Yes.
Okay, so now 153 minus 32.
121.
121 over 18.
Should be
Reduce
plus,
down, right?
or no? It should.
No.
Oh, it should be plus. Yes.
Good job, Madeline.
Thank you very much.
Thank you.
Go.
Okay. So the problem with what's going to happen here is the denominator is not going to be a perfect square, and in the book it is. So we'll talk about that in a second. Okay, so it's equal to 0, yes? So I subtract over this.
Yeah.
Okay, so I have x minus 4/3 squared minus 121 over 18. Take the square root. And I get x minus 4/3 equals. Now, 121 is what? What's the square root of 121? 11. Okay.
Good try.
So, and 18 is 9 times 2?
Yeah.
Yes?
So
So, I'm going to have plus or minus 11 over 3 square root of 2. I. Now, we can't leave the square root of 2 in the denominator. It's not a cool thing. Nah, can't happen. So if I have 11 over 3 square root of 2. You're going to review a bunch of math. It's called rationalizing, okay? If I want to get square root of 2 not to be a square root of 2, okay, I have to multiply it times itself, yes?
Yes.
That's the only way I can get rid of it. But if I do it in the denominator, I also have to do it in the what? Numerator. So I'm going to multiply
By 4.
square root of 2 and square root of 2. This is like conjugating, pretty much. Okay? You can't have an imaginary number in the denominator. You can't have a radical in the denominator. Can't have it. So, on the numerator, I get 11 square root of 2. Yes?
Yeah.
I'm just moving it, basically, as I'm moving it. Now, I have the square root of 2 times the square root of 2, which is what?
Square root of 2 squared. So
Which
that's
is
2.
2. Or 4, and square root of 4 is 2.
Yeah.
So 2 times 3 is 6. So now I'm going to put this down here. So I'm going to add 4/3, yes? So x is going to equal 4/3 plus or minus, and we changed this right here, didn't we? We just changed the form. So it's going to be 11 square root of 2 over 6 I. And do we even have it in standard form? Yes. Or in, the standard form of a complex number. So the fractions weren't too bad, okay? I am going to tell you in your assignment, the denominator is going to be a nice number. Okay, if I would have had, can I do a what if real quick?
Sure.
Yes.
Okay, if this would have came out to be negative 18 over 121, our life would have been fine. Because I would have taken the square root, yes? Okay, and the square root of 18 would be 9 times 2, so the square root of 9 is 3. So it would have been 3 square root of 2
And 11.
and 11 and I. And I can have that and I would be done.
Yep.
Does that make sense?
Yes, ma'am.
So I do not think your square root is going to end in the bottom, but if it does, tomorrow we can work through that together. But rationalizing is something you do need. Not that square roots won't show up or any roots won't show up in the denominator. We just can't leave them there. Just like we can't leave an imaginary number in the denominator. Okay? And I think we are done. Yes, we're done for examples for today. So today you are, first of them, the first ones, you are solving by using the square root like we did. Okay? Then you are just completing the square. And then you are solving by completing the square. If I want to solve by completing the square, all of those, can I? Yes.